Good evening, everyone. Welcome to 11th live session for the course Functional and Conceptual Design from IIT Madras. My name is Neelarnab Dutta. I am a PhD scholar and a PMRF fellow from Department of Design, IIT Guwahati. So, in this particular lecture, I will cover key concepts from week 11 lecture videos. So, have you gone through the videos from week 11? Because the deadline for assignments is tomorrow, which is 12th of October 2022. So those who have not finished the assignments, please finish them on time. And since nature of the assignments are objectives, so I'll not go straightly and talk about the assignment questions. So the nature of the this particular lecture session will be conceptual. So I will try to clarify some of your doubts. Those are important for solving the assignments. Okay, so let's talk about what we learned in the last class, in the last week. So, do you remember the key concepts that we have discussed? So, what we discussed in the last class was about the conceptual design process. We also discussed about various concept generation methods and issues with and the different methodologies. So, what is a concept? Can you tell? Yes. Okay. So a concept is basically an approximate description of a particular technology or a functionality of a product, okay, which is going to meet a particular customer needs or functionalities. So basically, the concept is a it's a approximate description. That means a concept can be altered, it can be modified, okay, it can be modified, okay, in order to satisfy customer needs later in the process of concept generation. Okay. So what we discussed in the last class was that in a concept design process, what we do is we use a systematic approach of developing concepts. So after we generate, after we do our functional decomposition. Okay. So so before functional decomposition, what we do? So basically, we used to have customer needs. Then based on the needs, we used to create specifications, right? And then we try to classify some of those specifications as constraints, some of them as functions, and then based on those functions, we try to do a functional decomposition of the product. Okay. Once we come up with various product functionalities, we then try to define the particular architecture by grouping various functions and making particular modules. So here we have various modules. Okay. So till this stage, and we have a a more like a theoretical understanding of how things needs to be done. After that, we enter in the concept generation phase. So basically, in a concept generation phase, we start with generating lot of ideas. So from a pool of ideas, then we concrete, make those ideas a bit concrete and convert those into concepts. Okay. So what is the difference between idea and concept? I discussed this in the last class. Anyone? You can use the message box. Okay. So basically, idea is something which is loose in terms of description. So it's a loose description of a product, approximate description of a product functionalities, and sometimes it is not connected well, not well connected. Okay, not well connected. Probably, for example, if you are making a coffee machine, okay, you can say that okay, coffee machine will be like a box, and then and there will be some sort of button, and coffee will dispense. But there is no interconnection of how this button button signal is converted into this particular dispensing mechanism. Those details are not there. So this is more like a very a high level non-connected loose description of the product. Okay, however, concepts are more concrete. So concepts are more concrete in terms of their feasibility. Okay, these are more feasible ideas. Basically those are ideas only, but those are more feasible ideas. There are more concrete definition of the product functionalities. The functions are defined and how they are interconnected and how they are what sort of interaction the user needs to do. All those user interactions, all those needs to be defined when you are defining a particular concepts. Okay, so this was what we discussed. Then we discussed about various issues of conventional approach of concept generation. So basically, conventional approach is that where we do not use any sort of systematic methodology for concept generation. So basically, the way earlier we used to develop concepts is like, okay, if we are from some particular background, and from the problem, straight from the problem, we try to come up with some sort of solution. So the problem in this particular conventional approach is that first of all, this particular approach end up having limited number of ideas. Okay, so we end up having limited number of ideas, and then also there can be bias, because bias of disciplines. Like if you are from mechanicals, and most of your ideas will be mechanical solutions, and if you are from electronics, and solutions will be electronics. Again, there may be issues like when you go to the production phase, you may actually face issues with development, because during the concept development phase you did not consider various aspects which would be probably more possible if you could communicate with other professionals, other experts in the field. Okay, so because of these issues, we go for more systematic approach, which are like, and there are two main categories. So other than conventional, so there is conventional approach, then we have the intuitive approach, and then we have the logical approach. Okay, so in the last class I discussed about intuitive approaches like brainstorming, 635. So these are more like more like using a group of people and ask them to generate ideas intuitively via divergent thinking. Okay, so the difference between brainstorming and 635 is that in brainstorming there is used to be a group leader. Okay, and generally the group leader along with other people from various technical background conduct a brainstorming session. So the group leader describe the particular problem, and the solution space he is looking for to the team, to the participants, and the a particular brainstorming session take place for around 30 to 40 minutes. And during the particular brainstorming session, the participants are encouraged to give wild and exaggerated ideas. Okay, and from after that, then from each idea the other people can go for building more ideas on top of other ideas. Okay. So at the end, the team leader records all the ideas. Okay, and he then try to generate some sort of memory map. So memory map basically nothing but he try to categorize and group various ideas, and try to see where particular solution lies, like where particular solution space lies. Okay, so I gave an example in the last class, like a for a medical device, like the for a wound healing device. So I showed you like there were solutions in the space of, like dressing. There are dressing solutions. So a lot of concepts come under, some sort of dressing for wounds. Then there are solutions for electrotherapy. Okay, again negative pressure wound therapy. There were solutions. So like that, we categorize various ideas using memory maps. And once we generate these memory maps, later we go for concept selection. The other process, which is 65, is a bit similar, but here the benefit is like, in brainstorming session, the ideas are not very concrete. Ideas are not supposed to be concrete, but exact working descriptions are not, uh, cannot be collected in a brainstorming session, because the ideas were generated mostly as a write up, or as a some sort of non-connected small diagrams. So it's not very easy to understand and to how these concepts are collected. So, and it is later it became a headache for the team leader to actually make a sense of all the sort of data he collects during a brainstorming session. So that particular problem can be addressed by using the method 65. So where there's a round table and there are six participants along with the team leader, and they were given papers and each particular uh, participants were given two papers, and they were asked to generate three concepts each. So once they finish their concepts, the paper needs to be passed to the next member, either in a clockwise manner or in a anti-clockwise manner, and then the other member then try to generate new concepts on top of the original three concepts. So this way, if initially there are three concepts, so now this person adds to three more concepts. Similarly, again this particular person will add another 3 plus 3 plus 3. So this way everyone's concept get multiplied, and in a particular session, a session ends when uh, each member get his own seat back after a five round of, not round, after moving the particular seat in five consecutive numbers. So in that particular instant we call this as a one particular round of 65, and that then again we continue that for another five sessions, and in between each sessions we take some break for discussions. So this way what we the benefit is like that, now since people are working at individual level on a piece of paper, so they get more time to elaborate their concepts or the ideas. Okay, so you get a more detailed record of information, and there's a less headache for the team leader later to extract those ideas. Okay, so I hope that much is clear. Okay, so last class we discussed that much. So in this particular lecture, I will cover another approach, which is again an intuitive approach of concept generation. So this is a combination of brainstorming and 65. So the limitation of brainstorming session was that the ideas are very much vague, and it is difficult for the team leader to later generate the memory map, and then to connect all those ideas to really develop concepts. So there is a second level of works always there with brainstorming. However, in 65, that particular problem gets solved, because from the very beginning the participants try to give a more concrete ideas. They try to give a visual representation of all the concepts in the sheet of paper. But the problem is here that, like, since here we use only six people, okay, so the number of peoples involved are less. Okay, and again, if the same people are being used for five consecutive sessions rounds, they get tired also, and nature of the concept that come in the later portion of the session is not very good, because people get tired cognitively. So, if we try to take the benefit or the positive of both these particular methods, both the brainstorming and 65 methods, what we end up is something known as gallery method. So this is a bit it is like a combination of both the two methods. So in this particular method, again the group leader, he presents the problem and explain a particular context. For example, if you want to develop some sort of device or product, you try to explain the customer requirements. Okay, so and the problem the customers face. So and the context where this particular product is going to be used. All those things needs to be told by the team leader beforehand to all the participants. And in the very first step is then to generate ideas. So each participants, so this is like a brainstorming session, so there is no limitation like 6 members only. You can have more than 6 members, so you can have like 15 member in a like in a brainstorming session. However, after the group leader present the problem, the participants were asked and given a 15 minutes of time to create solutions, in a piece of paper or in a blackboard. Okay, and preferably the participants are asked to generate some sort of sketches to define their ideas. Okay, so this is very similar to the round table thing, like where the participants have to give 3 ideas in the form of a sketch. But this is like a brainstorming session also, because here we have more than 6 people, and they are also asked to generate ideas in the form of a sketches. The next is like association steps. So in the third step, what you need to do is like all the participants are asked to hang or to place their sketches against some wall or in a table. Okay, and then all the participants review the concepts for 15 minutes. Okay, and they were asked to give their feedback, like what they think needs to be removed, what they think needs to be enhanced. All those feedback, the participants and everyone tries to give to all the concepts. And then a second level of concept generation happens, where again the participants were asked to come up with new set of ideas, because after this particular discussions, people get enlightened by others thought processes. So it is more like building on top of others. So this is very much similar to the original concept of brainstorming, where you need to build on top of other concepts. So this is similar, but you again have more concrete uh, concepts in terms of feasibility. So this particular process can be iterated for multiple phases. So we can like go up to like 10th step. Okay, so it depends upon particular problem. If a problem is very complex, then actually you can go for multiple rounds. But if a team leader gets satisfied with results, then he can stop a particular session, and then he can stop the concept generation phase, and then he can go for the selection step. So during selection steps, basically, so in between 4 and 5, there can be a break, okay, some sort of tea break, and then the team leader arranges a selection step process. So where all the ideas, whichever is generated, are reviewed and classified, and if necessary, are finalized by the reviewers based on a collective decision making. And during this particular intuitive process, the team leader can ask various questions to the team members, which may help the members in triggering some of the concepts, ideas. So the possible kind of questions can be like, how can we adapt this particular mechanisms, or how can we modify this particular portion. So during this particular association steps, where people discuss others concepts, then we can ask this sort of questions. Okay, can we reverse this, can we combine this, rearrange, eliminate, is there a new way of doing this, so etc. So likewise, you can trigger the participants with such idea generating questions, so that in the later stage, when they move from association steps to the next ideation step, they get triggered by those research, those key questions, and then generate fresh concepts. Okay, clear? If you have any doubts, please feel free to ask. So you can use the message box. Okay. uh, okay, so next is the logical method. So what is a logical method basically? See, what happens in a intuitive intuitive method is like, first of all, there's a requirement that you gather information from a group of people who are experienced, okay, from in diverse field. So you need to have a team having diversified domain expertise. Okay, that is same you also require in a logical method. But the way how these ideas being generated, there is no proper logical explanation, because it's more like the intuition, what how a particular participants come across, come up with a particular concept, is always based on what is his previous experience, okay, what he had seen in the nature, or what he thinks, by the process of analogy, okay, by process of analogy or any sort of exposure, his prior experience, okay, all those things matter when actually you generate concepts during a intuitive methods. And before that also, you need to actually collect information, okay, collect information about various technologies, various possibilities, before you coming up with some sort of ideas. Okay? So this is what is a intuitive process. The limitation is that in a intuitive process, okay, most of the time, like you, there's a high rejection ratio between the ideas generated. For example, if you generated 500 ideas in an intuitive process, probably only 40% or 13% probably will be useful. Okay, so this means the effort you put in generating those concepts is not justified in terms of the actual realized concepts you can actually have at the end of a intuitive methodology. However, it's not like that, like you can avoid intuitive method and only go for a logical method. In sometimes logical methods also cannot justify much, and even an intuitive method actually can give you greater results, because anyone can participate in an intuitive method, and for logical method you needs to have to be a bit smarter, okay, in terms of logical reasoning and analysis. So basically, in a logical method is more like a systematic analysis, okay, of various requirements, functionalities, and then trying to develop concepts, in a more logical manner. Okay, that is what is a logical method of concept generation. So in this particular class, so I'll be discussing one of the very popular logical method, which is called trees. Okay, so the trees is a abbreviation for a Russian word. So in English, it is called TIPS, means theory of inventive problem solving. Okay, the same when you can translate this particular English into Russian, the abbreviation you end up is trees. Okay, so this was developed by a Russian scholar, who is Genris S. Altshuler. And what was his research that he searched and analyzed over 400,000 patents, okay, in order to check in some sort of relationship between novel uh, design solutions, okay, novel design or inventions, and how this can be achieved, okay, using some sort of systematic methodology. Is there any ways how we can actually make a tool so that the tool can be used to come up with something novel and inventive? So what he find? So okay, he find. So he analyzed 400,000 patents. So you need to know one thing: for a patent to be grantable, you need to fulfill three criteria. First is novelty. That means the particular technology or particular description of a product is not being published anywhere. So this is the first time. So that means it is novelty. Second is inventive step. Inventive step means for a particular technology, for a person skilled in the art, that should not be an obvious solution. Okay, for example, if you are a mechanical engineer and you do not have a knowledge about probably computer science and or electronics, then you may come up with a electronic solution, and for you, since you do not have a domain expertise, you may think this is a very novel idea. But for a person who is skilled in that particular field, for him it may be a very obvious idea. So basically, inventive step means your idea needs to be verified by someone who is a domain expertise, and for him your idea needs to be a non-obvious solution. That is called the inventive step. And the third criteria is usefulness. So it cannot be something useless product, though it is novel and inventive. It needs to have some sort of practical use. Okay. So these are the criteria. Now, what this particular researcher have analyzed is that, according to him, what he find is that every patent actually is a solution to a contradiction. So, what is a contradiction? A contradiction means, so there are two patents, okay, and there are patents. A new invention, come into picture when it, find a solution to a contradiction. Again, for example, let's say bike engine. Okay, so a particular patent exists in terms of bike engine. Now, if you say like weight of the engine versus the horsepower, okay, so a bigger engine only can produce more horsepower, right? So a 300 cc or 600 cc engine cannot be a small engine. So because you need the piston, the cylinder size, okay, and it can be like four stroke. Okay, it can be parallel, twin, parallel, or serial, like all those, V twin. Okay, so all those configuration can be there. However, one important fact is that there is always a clash between the horsepower, the bhp of a particular engine versus the weight. Okay? So these are contradicting. That means if a particular patent exists that okay, my engine produce 31 kilonewton of power. Okay? However, the weight of my engine is 100 kg. So the speed in which you can ride the bike will reduce because the weight of the engine. So a new patent may come which says like okay, I am achieving 300 kg newton, but now I make the engine by only 95 kg. So basically, a solution is also always address a contradiction, what he tries to define. Similarly, like if you see patents on any particular product, for example, Apple phone, if there are patents on phone, okay, there are some sort of contradiction probably. probably the display size versus the way you can hold a particular phone. Okay, so you cannot have a large display, and again you want to have a good ease of use, okay, and ease of navigation. So those are the constraints, within which actually people design, and always new patterns, new solutions come into picture when you try to address a contradiction. So that was his what that was what he identified by reviewing these 400,000 patterns. And later what he identified was that this contradiction, all sort of contradictions, can be generalized into only 39 engineering parameters. That means he's trying to make he trying to reduce the effort of a designer in in trying to looking for various functionalities or parameters, or the issues, by reducing the number of engineering parameters that define all sort of novel ideas into only 39. Okay, so this is something interesting. And later he said like these 39 engineering parameters which contradict with each other. So this the nature of the parameters can be like here, like weight, okay, then power, okay. So like that he said there are 39 engineering parameters, and if you feel that in your design, because you are increasing something, it is conflicting the interest of another parameter. So this is parameter 2, this is parameter 1. If you are increasing something and the other parameter decreases, that means that is a particular parameter what you need to consider, for concept development. Because for others, if you are increasing something and that particular thing also get increased, okay, then you don't have to actually think crucially for generating new concepts. You can always keep on increasing this particular parameter and let this particular parameter also get increased. However, the desire is to reduce this, and because you are increasing this particular thing get reduced. Okay, so that is a contradiction. So he said like if you can identify such engineering contradictions out of those 39. So he said there are 39 engineering parameters, and out of those 39 parameters, if you can identify your design contradictions, then you can actually there's a checklist from of 40 engineering principles, and from that you can identify your solution, and using those engineering principles you can actually generate concepts. Okay, so let me clarify these things. So suppose you have a problem. Okay, so problem, for example, the bike engine example, bike engine. So the contradiction here is that bike weight, okay, versus the bhp, the power. Okay, okay. So the first thing that actually you try to identify is the contradictions. Okay, and what he said is like there are 39 engineering parameters which define all sort of you know uh, contradictions. So basically these are examples like weight of a moving object, weight of a stationary object, length of a stationary object, area, force, velocity, pressure, shape. So likewise there are 39 such engineering parameters. If you consider those, that will be enough for any sort of concept solution, or for considering in the concept generation process. Next, what you do, you try to figure out you try to figure out what are the contradictions. For example, here if you see the weight, so weight of a moving object, so your bike is the weight and probably speed. Okay, so speed can be a contradictions, but it says, okay, see, so it says if there is a speed and weight contradiction, you need to consider these engineering principles. Okay, and these are the 40 engineering principles. What he said, like if you consider these engineering principles as a solution to the contradictions, you will have some sort of, so you can have some guidelines, so easy way to generate concepts. Okay, now these are also very abstract, not like, as a, they are given as solutions, but those are given more like a, some sort of engineering principles. So for example, segmentation, so you basically you divide, you break down a particular mechanism or technology, whatever it is. So extraction, so take out something. Okay, then like asymmetry, make something asymmetric. Okay, combine something, consolidate something. Okay, make something universal, multifunctional. So likewise you have these principles, and see how this can be done. Like for example, in a bike, weight versus bhp would be, for example, uh, I think we do not have here. So likewise you have 39 by 39 matrix. Okay, so let's say not bhp, let's say uh, speed. Okay, speed of the bike. So if bike will have more weight, it cannot go much faster. So if only reduce the weight, it can go faster, but again the power will decrease, right? So this is a contradiction. Like now, if you see here, this particular matrix is called contradiction matrix, and this tell you that for this particular contradiction you need to consider 2, 8, 15, and 38 principles. Okay, so let me identify these principles. So these charts are available. You do not have to remember these charts. So these are some ways, some easy way how actually you can. So one is extraction. Okay, two. So then counterweight, then dynamics, and then 38 accelerated oxidation. So see, now you have these principles, these four principles which you can use for your concept generation. So what are these principles? You use the principle called extraction, you use something called counterweight, then you use something called dynamics, then accelerated oxidation. Okay, so see, now based on these principles you can think like, okay, extraction, probably you need to reduce or extract, remove some material. Probably you need to consider some sort of alternative material, so you can achieve the same horsepower. Okay, and reduce the weight. So you can think of extract material. So for your engine, the cylinder, you consider the same shape, but you would now think about alternative material, or alternative, or take out some portion of unwanted material, and think about restructuring the engine more, giving the same strength by changing the structural integrity, trying to give, um, trying to reduce the material, and trying to establish the same strength by giving some sort of this sort of functional structural arrangement. Similarly, counterweight. So basically, since it's a dynamic weight, when you move, probably if you think like the weight makes it difficult to balance, okay, in a high speed. So probably you can shift the weight of the bike and balance the CG in such a way that at high speed also it is easy to balance the bike. Okay. Similarly, dynamics, like you can also think like during motion, can we take the benefit of this motion so that the weight can be reduced. For example, if you try to create some sort of aerodynamic shape or some sort of aerofoil structure, probably you get some sort of airlift, and you will try to reduce the weight of the bike. Okay. This is how actually aircraft flies, although it's have very much weight. Because of the particular shape, it gets the drag force and a lift force, and because of that actually it flies. Okay. Similarly, similar concepts you can think about, okay, using this particular principle. Then what is that, accelerated oxidation, probably if it is if you use high combustion petrol, probably or you use multiple spark plugs. Okay. So the combustion rate will be faster, so you can still achieve higher speed, although the engine is a bit having a more weight. So this is an example like how the trees can be used, and as a tool, what you have is you have 39 engineering parameters, you have a contradiction matrix, and you have a 40 engineering principles. And based on that, actually you can actually then go for concept generation, and this makes your life a bit easier, because now you don't have to come up with 500 solutions and end up selecting only 40. So here the rejection ratio will be far less, because it's more systematic and more logical in nature. Okay, clear? Okay. Okay, so here's another example for trees. So in this particular example, I'll be talking about how we can use trees technique for conceptualize a electric iron. So basically, a electric iron is something that we use for making wrinkle-free our clothes. Okay, so after we wash our clothes, you get in our like t-shirts, in other clothes we get lot of wrinkles. The reason being, like the way the cloth get dried, the ridge line or the various uh, the patterns that actually get formed while keeping the cloth in a moist state, when they get dried, we used to have those wrinkles. Okay. Although this is like a wet cloth, because if you keep this particular cloth in some bad form, then you used to get those wrinkles. Now electric iron, what it do, it tries to heat up and the fabric and try to create straighten these wrinkles and make a particular cloth wrinkle free. Okay, so that is the purpose. Okay, so everyone knows that, so I just try to explain you these things, the logic, like how and why this happens, and how we can use the trees method to uh, get some concepts out of it. So the problem that we face with the present days uh, basic electrical iron boxes are that they are very lightweight. So lightweight is good one way, that it is ergonomic and it is easy to handle. Anyone can do a iron job. However, because of the lightweight, clothes do not uh, get wrinkle free easily. Earlier, we used to have the heavy metal irons, and some of them are electrical also, and some of them are like charcoal based. but because they have some sort of their self weight, it is very much easy for them to get press or make clothes wrinkle free. So the problem is that heavy iron make ironing easy. However, heavy iron is difficult to use and require more force. Okay. Similarly, the other part is like if you use a lightweight, uh, ironing ironing is difficult, and by ironing means not ease of use. Here, ironing means you are trying to make the cloth wrinkle free. Okay. So the conflicting parameters. The first thing you try to identify here is that what is the conflicting parameter. So you have a list of 39 engineering parameters, and you try to identify what sort of engineering parameters you are trying to identify. Okay, you are trying to use, in your concepts. So in your concept, you try to use here like weight of a moving object, yes, and probably the force. Okay, so you need more force, physical effort. So basically this is manual force. It's not gravitational force, it's like human manual force that you require for pressing. And it's these two things are contradicting. Like if you require more weight, if the weight of the iron box is more, you need less force. However, if you increase or if you reduce the weight, you need more force. Okay, and also, if weight is less, it is easy to handle. Okay, so if you next is you try to check the contradiction matrix. So this matrix tell you like, okay, these are the two uh, parameters that are actually conflicting, okay, in nature. So based on this particular contradiction matrix, you can identify what sort of engineering principles you can consider. So here it says 8, so counterweight. Okay, again 10. 10 is prior action. Then 18 is vibration, and 37 is thermal expansion. So these are the four these are the four principles that you can use for your concept development. So what are those concept counterweight? So let me check here how we can use this. Okay. Okay, so counterweight. So counterweight means anti-weight. Probably, you may think about you are having a uh, light iron box, but you want to make it heavy while operation. Probably you can think about some sort of magnets or some sort of metal below, and in between you put your cloth, and as the electricity goes inside, this thing became like magnetic. Okay, and this, because of this particular magnetic force, okay, you feel it is heavy although it's a lightweight. So only while pressing, while supplying electricity, only this thing get heavy, and then you can make use of it, and you can easily slide it over this particular metal piece, and this thing actually this can easily make this particular cloth wrinkle free. Okay, next is prior act. Okay, so prior act is something like, you can think about you have a electric iron. Okay, and what you think of this? Sorry for interruption. Okay. Uh, Sorry. Okay, so you have a electric iron, and you need to do some prior act in advance. So probably For counterweight, probably you can think about, okay, you have a lightweight electric iron, and you think about, okay, you first give some sort of steam, steam to the cloth. Okay, and that way even lightweight iron also can be used for doing good ironing or pressing. Okay, and vibration, so you can think like, okay, while the cloth is in a wet condition, why don't we vibrate it and vibrate it till, so we just try to vibrate the whole thing, lets the wrinkle get away, and let the cloth dry in a vibrating mode only. So probably you will not have any sort of crease lines, because vibration will remove all sort of lines when it's in the wet condition. And then you can think about thermal expansion. Okay, so how thermal expansion can be used? So probably, you can have a small sized iron having a reduced size and shape. That's why the weight is low. But because as it increases the heat, the size, the bottom size get increased because of thermal expansion. And now you can use this iron, although it's having the same weight, it can press a larger surface area. So this way also you can counter weight. Okay, so these are various concepts like I have generated just now. And imagine like I don't have to intuitively come up with 500 solutions or 50 100 solutions, and out of which I need to just arrive at these 5 solutions. Straight away I can go for these principles, and then using these principles I can come up with many concepts. Okay, so that is the benefit of using a more systematic methodological approach in concept development, and which trees this particular methodology provides. Okay, so I think that much is clear. Okay, so next is your concept selection phase. Okay, so this is the last phase in a product design process. And what we do in a concept selection process is that from a set of initial ideas, okay, or set of initial concepts, okay, we try to evaluate the concepts and then come up with to a number which can be workable, which can be later go for testing for further product development. So for example, in the concept generation phase, we end up having for example, you end up having 100 ideas. Okay, so these 100 ideas are initially ill-defined, and later you convert them into 100 concepts by getting more, by putting more details into it. And then what you do is like you try to screen those concepts, so based on your requirements. Okay, so you need to have some sort of feasible, some sort of criteria which actually you can use for screening. Or you can also screen based on reliability, feasibility, or you can reject a set of concepts at the initial screening phase. So at this, after concept screening, you end up having some 30 concepts. So this initial filtering of 100 concepts to 30 concepts generally does not happen if you use the logical methods, but it happens if you use those intuitive methods like brainstorming or 65. What happens like here, the people who participates are not they are from different backgrounds, and everyone's concepts are considered. And in a brainstorming session, it is encouraged to get wild and exaggerated ideas. And many times the individual ideas may not be feasible or may lack certain intricate details, because they may not be a domain expert in this particular area. Okay, so out of so many concepts, you reject a lot of them based on your requirements. Okay, so these initial concepts, like 30 concepts you generated, you then next go for concept scoring. That means now you use some sort of empirical method to, to come up with some sort of concepts which are more appropriate for your particular task. Okay, so for to score or to rate the concepts, you need some sort of criteria. Okay, so what are all these criteria? Can you tell? Okay, so customer needs, right? So as we initially discussed in the lecture 2, lecture 3, like we design concepts based on customer needs. Now customer needs are qualitative in nature, like for example, portable, okay, fast, okay, user friendly. So those are very much uh, qualitative in nature. So we can consider customer needs also as our need criteria, and also we can consider other concepts like no, other criteria like criteria functional requirements. So once you convert these customer requirements into specifications, and then from the specification, when you identify some sort of functional requirements, you can use those also as uh, criteria to score and rate concepts. Okay, and based on this scoring and rating, you then finally select few concepts, one two concepts that you actually later evaluate based on testing. So based on user testing, by developing some sort of initial low fidelity or detailed modeling, you actually go for concept testing, and later you can finalize one or two concepts for production. So this is basically a brief idea how concept selection is done. It involves, so after concept generation, it involves first concept screening, then concept scoring. So this is an empirical way. So we use some sort of need some sort of matrices. Uh, okay, and we have some sort of criteria, and we have various concepts, and we try to rank or rate these concepts against these criteria. And then after getting the particular ranks, we selected something like that's get the highest rank, and then later we go for concept testing. Okay, so let me give an example, like in the last class we discussed about the this particular project where we used brainstorming to generate ideas for a wound healing device. And as we discussed in the last class, that uh, as concepts we generate a lot of concepts in different domains, different solution spaces. So there were concepts which were based on antimicrobial dressing. So these are all for wound healing. So you have non-healing wounds, like diabetic foot ulcer, pressure sores, and it's very difficult to heal those wounds by using standard dressing techniques. Like if you go to a medical facility, and if you have some wounds, then they will straight away do dressing, and they will clean your wound. They will do some sort of debridement. They will put some ointment, and they will use some sort of cotton dressing to wrap around that wound site. So that's a standard procedure. But in certain chronic wounds, like diabetic, because of some underlying condition, it is very difficult to heal those wounds. So in those cases, we need some special technologies. So for this particular projects, we generated various concepts using a brainstorming session, and these are the various solution spaces that we could generate. So another was electrotherapy, and then we have ultrasound based solutions, then mechanical suction based solutions, then NPWT and cold plasma. So let's see, like, how can we use the concept selection process for this particular set of concepts. So the first thing, like, let's assume that we have six concepts after concept screening. Now, this particular concept selection procedure can be done in multiple rounds. Let's say in the first round, we want to identify the solution space. For example, within electrotherapy, we can have multiple concepts. Similarly, within antimicrobial dressing, we can have multiple concepts. So first, we want to figure out like which particular solution space or the area will be most suitable for our purpose. So let's say in the initial phase, using concept selection, so you have six areas and you identify a particular area. For example, ultrasound based devices are the best. Okay. Next, again, you can do for concept selection, and within ultrasound, if you have eight devices, then you can again do a another round of concept selection, and there actually you can select particular few, like one or two ultrasound based devices, and then you can go for user testing of those concepts for further selection. So very first thing you do in this particular case is like you prepare a selection matrix. So selection matrix is basically something where you arrange your criterias based on which, for example, here probably effectiveness. Okay, effectiveness of healing is a criteria, portability is a criteria, probably skill dependency can be a criteria, power, use of power can be a criteria, and also like safety can be a criteria. So you make a matrix, okay, which is called a selection matrix, and you evaluate various concepts by giving them a rank or rating rank. So there are various matrices available. One is called Pew's matrix, and there are other matrices like weightage index matrices. So there are different matrices which you can use. So in this particular, I'll give an example of past Pew's matrix in the next slide. So what you do after you generate the selection matrix, you rate the concepts. So you rate the individual concepts. Okay, like for example, you scored some, like, okay, effectiveness, you scored, okay, this is good, this particular concept do not provide this. Okay, so like you can give, if you use Puke's matrix, you generally use plus minus or same. If it is same, then it is it is zero. If you use a weightage index matrix, you use some sort of scale. For example, you can use 1 to 5 as a scale. So efficiency you can give like, okay, 3, this is like 2, like 1. So like that, the different matrices can be used. So once these matrices were created, then you give the particular rating, okay, based on your scale. Okay, and then you add those and to see which particular concepts get the highest rating. So the concept which gets the highest rating get the, you then rank them accordingly. So this is like, if this particular concept gets the highest ranking, the highest rating, you give it a first rank. So this is like the most appropriate solution. Okay, if this is the second rank, this can be like the fourth, like that. And during, at the end of ranking, you can also see if certain concepts can be combined, okay, in order to arrive at a better concepts. Okay, that also you can do. And then you reflect on the results, you discuss on the results, like which way this particular concepts can be combined, how this particular concepts can be useful for this particular purpose. So likewise, so let me give a detailed example here. So suppose this is the same problem. So you are supposed to select one or two concepts from these six initial concepts. So these were antimicrobial dressing, electrotherapy, mechanical suction, ultrasound based devices, NPWT, and cold plasma. Okay, and this is a particular matrix which is called Puke's matrix, and this is also a very standard matrix that is being used for concept rating and ranking. So what we use here is we use at one side a reference standard. Okay, so a reference. Okay, so based on this particular reference, actually we try to rate the particular concepts as negative, positive, or same. Okay, so initially, for example, we are comparing these concepts against a standard dressing procedure. Okay, we are comparing them against a standard dressing procedure where basically when you went to a hospital with some sort of wound, you first go there and the doctor first clean their wound, then they do some sort of debridement, they give some sign, some sort of antimicrobial treatment, and then they start the dressing procedure. So this particular process is a bit hectic. Okay, and you need a lot of skills, and also you need to have the professional certification to do this particular job. You cannot do it at your home, and the kind of solutions and the kind of tools that's being used in this particular procedure, the standard clinical procedures, cannot be available in a home-based scenario. So we will evaluate all our concept against this particular reference. Okay. So in Puke's matrix, we use a single reference and then we try to compare the other concepts. And later we can compare based on their scoring all different concepts. So for example, let's see here. Like for example, if you consider a antimicrobial dressing. So antimicrobial dressing is nothing but like a pets, and you have some sort of antibiotics. Uh, there are different technologies by chemicals that can have these particular antimicrobial properties. So this is a ready-made bandage like kind of thing which can be used for any sort of wound. So in terms of cost, okay, this is a bit costly because of the material used. So you can say this particular feature is a negative feature. Okay. Similarly, technical complexity means in terms of complexity of use, you say like, okay, you see this is a bit more complex. Okay, safety wise, this is same. Ease of use wise, this is same. Portability, you said, okay, this is a bit more portable. This is good. Okay. And then, okay, sorry, tech complexity means it's less complex. Okay. So we are giving here plus means we accept technical complexity of this particular dressing in comparison to the standard procedure. That means this is less technical complex. That's why we are accepting this as a plus. If we are saying this is more costly, we are saying it minus. Now this is not, this is a negative feature. This is a positive feature. This is like a same feature. So portability is a positive feature. Effectiveness. So effectiveness against wound is a positive feature. It is more effective than a standard dressing. Similarly, electrotherapy is a bit more costly, so it's a negative feature. Technical complexity is more, that's why it is a negative feature. Safety wise, it is more safe. It's a device, it doesn't involve any human error. Then it's a easy, it's a ease from ease perspective, it is again a positive feature. Portability, it's a portable device. It's very effective against in comparison to standard process. And mechanical suction are again it will be costlier, so it's a negative feature. Technical complexity is there, it is again negative. Safety wise, it's not again very safe because there's a mechanical springs and mechanism involved, so it's not always very safe because if you see the particular concepts, actually you have some sort of spring mechanism and it tries to extract the exudates in a mechanical by generating some sort of mechanical suction pressure. So safety wise it is not very safe in comparison to standard procedure. Ease of use, yes, it is ease of use. This is positive. It is portable, yes. Effectiveness, it is effectiveness in terms of the principle. Okay. Ultrasound based. So ultrasounds is again it is costly, so negative feature. Technical complexity is it's quite complex, so which is a negative feature. Safety wise, it is safe. Okay, ultrasound is quite safe. Ease of use is safe. Portability is safe. Effectiveness is effective. Effectiveness, actually it is a bit doubted, but it is something like you can consider it same. Okay, because there are not lot of evidences against effectiveness of ultrasound based device for chronic wounds. Okay, so you can say zero, same. Then negative pressure. So negative pressure cost is a bit high, negative. So then technology complexity, it is complex, negative. Safety wise, it is very safe. Ease of use is portability, yes. Effectiveness, very very effective. Okay. Cold plasma, very costly. Technical complexities, again, very complex. Safety wise, not very safe. Okay. And the ease of use, it is not very, it cannot be used by someone who is not skilled in this particular profession. Okay, so it cannot be, it is a prescribed concept. It's prescribed technology. It cannot be used by someone sitting at home. Portability, it's a portable device and it is effective, yes. So if you try to consider a total positive here, like 1 2 3, so 3 positive, then same is like 2, and total negative is 1, right? So here if you say total positive 4, and this is same, nothing, like same is 0, and total negative is 2. So now we are trying to check the aggregate scores for each particular concepts. So you have 3, then 3, so total 3 positive, 3 negative. Here again ultrasound based is 3 positive, 1 same, and then you have negative, 2 negative. Then for this you have 4 positive and 2 negative, and here you have 2 positive and you have 4 negative. So overall, if you see, you have to now subtract negative from positive. So it is 3 minus 1 2, this is 2, this is 0, this is again, if it is same, then you can say there is, you can consider this actually, because if same means it's already there in the standard. So you just consider the positive and negative only. So it is 1, this is 2, and this is minus 2. So if you see, there are 3 devices that scored actually same. Okay, that means you rank those as 1 1 1. This is the ranking 2, this is the ranking 3, and this is like the ranking 4. So as a concepts, you will look for concepts, uh, like you will look for solution which are based on antimicrobial dressing, electrotherapy, and negative pressure wound therapy, NPWT. So this is the first round. Like later again, you can go for the second round. Like within that antimicrobial dressing, which all concepts you want to score higher. Okay, and then again you can do ranking and you can select a particular, one particular antimicrobial thing. Again for electrotherapy, you can do the same process. You can select one electrotherapy. Similarly, negative, you can do one. Then again within these three, you can again go for another round of concept selection, and then you can select one or two ideas, or you can actually consider all the three and go for concept testing, and where actually finally you can decide on which particular concept is better based on user validation. Okay. Okay, so that much is there for today's lecture. So if you have any doubts, please feel free to ask. Okay, is it clear? Like your the concepts related to trees and parametrics? Okay, okay, okay. So next class is again next Tuesday, and the deadline for assignments is tomorrow. Okay, so if you have not finished the assignment for week 11, please finish them on time. Thank you.